Okay, guys, we're going to go over the Check Your Understanding on page 91. Miss Narvard's statistics class has just completed the first 3 steps of the Where Do I Stand activity. The figure below shows a dot plot of the class's heights distribution along with some summary statistics. Come over here. So I can see the sample size, the mean, standard deviation, and then my 5-number summary. Okay. Number 1 says, Lynette, a student in the class, is 65 inches tall. So there she is. Find and interpret her z-score. Are you over here so you can see Lynette? Okay. So find and interpret her z-score. Come down here. Let's remember that the z-score formula is x, or the data or the observation, minus the mean divided by the standard deviation. Okay? So to solve for her z-score, her height was 65 inches. Okay? Minus the mean, come up here, the mean, which is 67, divided by the standard deviation, which is 4.29. Okay. Stick that in the calculator, and we get negative 0.47. Okay, so that's her z-score, negative 0.47. Let's interpret. So Lynette's height is 0.47 standard deviations below the mean height of the students in her class. Okay. Below is the negative. Okay, so there's calculating z-score and an interpretation. Scroll up just a little bit. Okay, number 2 says, up here please. Another student in the class, Brent, is 74 inches tall. So there's Brent. Over here so you can see Brent. There's Brent at 74 inches tall. How tall is Brent compared with the rest of the class? You can hear Kitty's toy. Give appropriate numerical evidence to support your answer. Well, our numerical evidence is going to be a z-score because we use a z-score to compare individual pieces of data against the whole distribution. So again, we'll come down here and do our z-score formula. Brent's height was 74, so that's my data, minus the same mean, which is 67, divided by 4.29, which is the standard deviation. Throw that in the calculator, and Brent's z-score is 1.63. So to interpret his z-score, Brent's height is 1.63 standard deviations above the mean height of students in his class. Okay. So above is the positiveness. So if you look at both of them, Lynette's a little bit below and Brent's a little bit more above. So who's further away from the mean? Okay, Brent is the more you don't need to zoom in on Brent. Brent's height is the what am I trying to say? Is the one that's farthest from the typical height, because the typical height is the mean. Lynette's closer to the mean, but she's less. But Brent is further away, so even though he's higher than the average height, he's further away. So he's actually further away from the mean. Okay. Last question says, Brent is a member of the school's basketball team. Now, the mean height for the basketball players is 76 inches. So our b-ball players have a mean of 76 inches, as opposed to the class that just had a mean of 67. Brent's height translates against his basketball players to a z-score of negative 0.85. So he's actually, his height's lower, is 0.85 standard deviations below the average height of the basketball players. Okay, so what's the standard deviation of the team members' heights? Okay, so come on down here. So we have the basketball mean and we have Brent's z-score. Let me put Brent with this. So we take our formula and we fill in everything we know. I know the z-score. I know Brent's height. What was Brent's height? 74? minus the mean of all the basketball players, and I don't know the standard deviation. A little bit of algebra. Oops, negative 0.85. So we calculate that the standard deviation is 2.35 inches, okay? So in this formula over here, I can ask for anything. As long as I give you 3 of the variables, you can solve for any of the other one, or any one of them, okay? Okay, great. Thanks. See you next time. Bye.